Welcome back to ICSE MathGuru. Today we are learning one more lesson, and today's lesson is ratio and proportion. A very simple lesson, children. You have learned this in standard 6, also in 7 and also in standard 8. You learnt about direct proportion, inverse proportion, reducing it to lowest terms, dividing a certain amount of money into 3 or 2 parts. All this you have learnt. Okay. So that simple it is. Add on to those basic concepts. You will have few more concepts added, but very simple. So nothing to worry, super cool lesson, super easy, and you can get all your marks from this lesson, ratio and proportion. So before we get further, children, ratio has been deleted from the syllabus, but the lesson still, the topic is still ratio and proportion. You will be getting only questions from proportion, but to know proportion, you have to know a little bit of ratio. So we have this lesson as ratio and proportion. Okay, so that's all about ratio and proportion, what I have to tell. Now we have to get into the lesson to know more what is there in store for us. So before we get into the lesson, don't forget to like, subscribe and share to ICSE MathGuru and hit the notification bell to get updated with the upcoming videos. So let's get started. Children, what is ratio? All of you know the definition of ratio, right? So ratio is nothing but it's a comparison of two or more quantities of the same kind with the same unit. Same kind and the same unit means that if you are comparing the weights of two people, the weights of both the people should be in kgs or in pounds. Similarly, if you are comparing the heights of two people, the heights of both the people should be either in centimeters or in meters, or if they want in feet. Okay, the unit should be the same. Okay, then only you can compare, and you write the ratio as A is to B, which is denoted as A by B, and A by B is nothing but the quotient. Okay, it is the quotient, and the first term of the ratio is called the antecedent and the second term is called as the consequent. First term is called the antecedent and the second term is called the consequent. Please keep in mind these two terms because we will be applying this when we do sums later further in the lesson. So antecedent and consequent are important terms to be noted. Coming to proportion. So extension of the ratio. When you compare two ratios, that is when you have an equality sign between two ratios, the ratios, the terms of the ratio are said to be in proportion. That is if you are comparing A is to B and C is to D. So A, B, C, D are said to be in proportion if A is to B is equal to C is to D, and when we read it as A is to B as, and this as is denoted as a double ratio. What do I mean when I say a double ratio? So you write it as, the pen didn't get selected, 1 second, okay. So we write it as A is to B as, this is the double ratio, okay. You read it as C is to D. Is that clear? So proportion is nothing but an equality between two ratios, okay, and four non-zero quantities are said to be in proportion if A is to B is equal to C is to D, and we read it as A is to B as C is to D. Just now I have told that, okay. Now A, B, C, D are called the first, second, third and fourth terms respectively, and D is called the fourth proportional to A and B and C. So the last one, D, is called as the fourth proportional because A is first proportional, B is second proportional, C is third proportional. D will be the fourth proportional to A, B and C. Okay. Also, product of means is equal to product of extremes. What is product of means and product of extremes? These two terms close to the proportion sign, they are means, and to the extreme ends are the extremes. So product of means and product of extremes is AD is equal to BC. AD is equal to BC. Is that clear, children? So that's already you have learnt this in your earlier classes. So I am going a little fast. Now continued proportion. Now this is where you have to come. This is something new. So continued proportion. So A, B, C, D are in continued proportion. When they are in continued proportion? When there is a continuity. What do you mean by continuity? Okay, 1 minute, I will reduce the thickness here. What do you mean by continuity? It means A by B is equal to B by C. There is a continuity. is equal to C by D, there is a continuity, is equal to D by E. If there is a continuity, then the terms are said to be in continued proportion. Okay. So, if A by B is equal to B by C, then what do we write? We write that A, B, C are in continued proportion. If only A, B, C, D are in continued proportion, then you need not write this. It is only A by B is equal to B by C is equal to C by D is equal to D by E. Is this concept of continued proportion clear, children? So, when do we say the terms are in continued proportion? When there is a continuity, that is the denominator of the first fraction becomes the numerator of the second fraction and it continues so on. So, is that clear? So, moving on. So, that is what is written, A by B is equal to B by C is equal to C by D is equal to D by E. Next is mean proportion or geometric mean. Mean proportion or geometric mean. Children, if you have only A, B, C in continued proportion, not in proportion, A, B, C, if they are in continued proportion, which means A by B is equal to B by C. B is continued. Now, either cross multiply or apply product of mean, product of extreme, whatever you apply, we know that B square is equal to AC. So, this is a very, very important result, a very, very, very important result. So, if A, B, C are in continued proportion, then B square is equal to AC. Of course, B is equal to root AC and B is called as the mean proportion or geometric mean. Mean proportion or the geometric mean. Okay? Mean proportion or geometric mean to A and C. Is that clear? So, if A, B, C are in continued proportion, we have B square is equal to AC, which means B is equal to root AC and B is called the mean proportion or geometric mean to A and C. Now, coming to third proportion. Children, I told you if A is to B as C is to D, what did we learn? We learnt that D is the fourth proportional to A, B and C. But if they are in continued proportion, that is if A is to B as, again B is to C. So, actually it is like the second rank sharing by two people. Therefore, the fourth ranker becomes the third ranker, right? If in your class you have the first rank and you have the second rank and the second rank is backed by two people, they get the same mark. So, they both become second rankers. So, the fourth guy becomes the third ranker obviously. So, similarly here C becomes the third proportional to A, B and C. Though it is in the fourth place, it is the third proportional to A, B. Why? Because this B is taking two places. So, let us learn properties of proportion. Children, these properties of proportion are totally new to you. You haven't learned it in your previous classes. But believe me, they are really very, very simple. So, let us learn these properties of proportion. Don't get worried looking at the terms, alternando and all that. Now, proportion. You all know that A, B, C, D are in proportion if A by B is equal to C by D. Now, the first property is alternando. Alternando, children, it means that the denominator and the numerator of these two ratios get interchanged. That is, you have it as A by C is equal to B by D. That is alternando. Next is invertendo. Children, invertendo means in this proportion, that is, each ratio gets reciprocated. That is, A by C becomes B by A by B becomes B by A and C by D becomes D by C. Always look at this ratio, children. Okay, just now I made a mistake. I was looking about alternando. No, you always have to compare with the original proportion that is given to you, that is A by B is equal to C by D. That is your invertendo. Inverse, remember alternate means change in places, invertendo means reciprocal. Next comes componendo. Componendo means adding. Children, I will tell you something here. It is numerator plus denominator by denominator. and you have to apply, children, all these properties should be applied to both sides of the proportion, that is to both ratios in the proportion, not just to one side and leaving the other side. It is not possible. So componendo is numerator plus denominator by denominator, and it is applied to both. So if you consider the ratio as, the proportion as A by B is equal to C by D, applying componendo, numerator is A, denominator is B. So A plus B by denominator B is equal to, same thing applied to the other side also, C plus D by D. That is componendo. Dividendo also is similar, children. It is numerator minus denominator. Dividendo is numerator minus denominator by denominator. This is dividendo. Okay. I hope this is clear. So if A by B is equal to C by D, if you apply dividendo, it is numerator A minus denominator B by B is equal to C minus D by D. That is your dividendo. Now the last one is very, very important one. You will be applying this very, very often in the sums if it is given as solve using properties of proportion. The most commonly used property is componendo and dividendo. Nothing, children, it is a combination of componendo and dividendo. So if you have a ratio as A by B is equal to C by D, again I said ratio, if you have a proportion as A by B is equal to C by D, by componendo and dividendo, children, it is numerator plus denominator by numerator minus denominator. It is numerator plus denominator by numerator minus denominator, which is the same to the other side also. So let us apply this numerator plus denominator and numerator. What is numerator, children? Numerator here is A plus denominator plus B by, remember that is where I have written it is not B minus A, it is numerator minus denominator. Okay. The same thing, numerator is C plus denominator is D by numerator is C minus denominator is D. This is the proportion when, this is the property of proportion, componendo and dividendo. So to a particular proportion, if we apply componendo and dividendo, it is the terms of the numerator plus the terms of the denominator by terms of numerator minus terms of denominator, and you have to apply it to both sides of the proportion. Okay. So that these are the properties of proportion. Now we will solve some problems from this lesson, proportion. Okay. So let's do some problems. The first one is, what number should be added to each of the numbers 5, 11, 19 and 37 so that they are in proportion? 5, 11, 19 and 37 so that they are in proportion. So these numbers as they are not in proportion. That's what they have told. So what do? We have to add some numbers. So let the number added be x. So we will add x to each of the numbers. So the numbers now become 5 plus x, okay, 11 plus x, 19 plus x and 37 plus x. Now these numbers are in proportion. If these numbers are in proportion, what does it mean, children? Can you tell me what does it mean if these numbers are in proportion? It means that, let me write, it means that 5 plus x is to 11 plus x is equal to 19 plus x is to 37 plus x. Now product of means product of extremes. Okay. So when you multiply 5 plus x into 37 plus x, what do you get? Actually you can tell it orally, children. So let's see here. So product of means and product of extremes. So how do you multiply? You have learnt this a plus x into b plus x multiplication when you were in standard 8 in expansions. So 5 into 37 is 185, x into x is x square, 5 into 37, okay, and 5x plus 37x is equal to 42. Why? Because 37, it is a plus b into x. Similarly here you have 11 into 19, which is 209, plus 11x plus 19x, 30x plus x square. X square gets cancelled on both sides. Okay, 42 minus 30 is 12 and 209 minus 185 is 24. Therefore, the value of x is 2. Okay, therefore, the number added is 2. Children, let the number added be x. You have to write. If you don't write this statement, write a closing statement. Sometimes they take away marks for not writing a statement. Okay, so write a closing statement. Now, the next sum, find two numbers such that the mean proportion between them is 24 and the third proportional to them is 192. Find two numbers such that the mean proportional between them. Children, what do you mean by mean proportion between any two numbers? We have learnt in today's class only that if a by b is equal to b by c, b square is equal to ac, and we learnt that b is called the geometric mean or the mean proportional to a and c. Now here it is given, find two numbers such that the mean proportion between them is 24, which means if the numbers are x and y, the mean proportion of these two numbers, okay, b square, b is the mean proportion to a and c. So here what is the mean proportion? 24. So 24 square is equal to xy. Okay, 24 square is equal to xy. 24 square is 576. So x becomes or y becomes 24 by y. So this is the first part given here. The second part is the third proportional to them is 192. Now, it is the same ratio, a by b is equal to b by c. Now, I told you that if a, b, c are in continued proportion, c is called the third proportional to a and b. So, here third proportional means this c place is replaced. So, what do we have here, children? We took the numbers as x and y. So, x by y is equal to y by 192. Which makes y square is equal to 192x. Y square is equal to 192x. So here you have one relation which is y square is 192x. Here you have another relation which is x is 576 by y. So using these two relations we will find the value of x and y. So let's see. So y square is equal to 192x and you have to substitute this value of y square, the value of x in this equation, y square is equal to 192x. So if you substitute here, you are getting y cube is equal to 192 into 576. Children, don't get worried looking at these big numbers, okay, and finding, and never ever sit and multiply and try to find the cube root. Finding cube roots for fractional or for decimal values is not there in your syllabus. So you always get a perfect cube only to find the cube root. So you all know that 576 is 24 into 24 and 194 is 24 into 8. So y cube becomes what? 8 into 24 into 24 into 24. From these 3 24s you take out 124 out because cube root. 8 is nothing but 2 into 2 into 2. 8 is nothing but 2 into 2 into 2. From this also 1 2 comes. So what did we get? Y is equal to 48. And what will be the value of x? 576 by 48. So that's simple. It is but a very important model. Okay. So if you want to make a note of it, please pause the video and make a note of the solution. Okay. So the values are 12 and 48. 576 by 48 is 12. Therefore, the numbers are 12 and 48. Okay. So let's see this question 3. If B is the mean proportion between A and C, prove that A square minus B square plus C square by A power minus 2 plus minus B power minus 2 plus C power minus 2 is equal to B power 4. So let's solve this sum. So children, if you see the numerator has all positive powers, but if you see the denominator, you have all negative powers. So first we will change the denominator to positive terms. Now how do we change? So the LHS here is, leave the numerator as it is. It is a square minus b square plus c square by a power minus 2 1 by a square, b power minus 2 1 by b square, c power minus 2 1 by c square. The LCM is a square b square c square. For the denominator, okay, the LCM for the denominator is a square b square c square. So what do we have, children? We will have as a square minus b square plus c square by, here we have b square c square, and second term we have it as a square c square, and third term we will have it as a square b square whole by a square b square c square. This is the denominator I showed you all for better understanding. Now what happens to the denominator of this fraction? It gets multiplied with the numerator. So a square b square c square into a square minus b square plus c square by b square c square minus a square c square. A square c square, if b is the mean proportion between a and c, we know that b square is equal to ac. So a square c square becomes b power 4 plus a square b square. From this we can take out denominator. From the denominator we can take out b square common. So if we take out b square common from the denominator, we have a square b square c square into a square minus b square plus c square by b square into c square minus b square plus a square. So this and this gets cancelled, b square gets cancelled. So we are left with a square c square, which is ac whole power 4 whole square, ac whole square, and ac is b square, so it becomes b to the power 4. Okay, so this is how you solve a simple question, children. Very easy, only you have to be strong with your algebraic simplification. Okay, so see the solution. This is the solution. B is the mean proportion between a and c, and therefore we have it like this. If a, b, c are in continued proportion, here also a, b, c are in continued proportion, prove that ab plus bc plus ac by a plus b plus c is equal to abc. Children, both mean the same. Mean proportion, geometric mean, continued proportion, all three mean the same. So if a, b, c are in continued proportion, it means b square is equal to ac. Okay. So here the LHS AB plus BC plus AC, I will write here as B square. So we have AB plus BC plus, in place of AC, I will write B square by A plus B plus C whole cube. Now what is common in these three terms? We have B common. Let me go up a little. Yeah. We have B common. So when we take out B common, we will have in the numerator as A plus C plus B by A plus B plus C, okay, and then you have whole cube. You have a whole cube. These two get cancelled. So here you have B cube. Now here in this question they want us to write in terms of A, B, C. In the previous question they asked in terms of B. So this B cube I will write it as B square into B. B square is AC into B, which is nothing but ABC. Is it not simple? Both the models are close. I just picked up this because I wanted to show you how you have to reach to the answer. When B cube is given, you have to, and I mean when the answer is in terms of ABC, you have to write in terms of ABC, splitting B cube as B square and B. In the previous question it is the other way round. Okay. Now let's see the solution. Yeah. This is the solution. If anyone wants to make a note of the solution, same thing, please pause and make a note of the solution. Let's see the next question. Using properties of proportion show that, children, this is really very important. First thing is that when they say using properties of proportion, remember that you have to apply proportion to both sides of the proportion. So x by 1, most children do not write x by 1, so that is the first key step. X by 1 is equal to this. Now when I apply properties of proportion, that is I will be applying by componendo and dividendo. So this becomes x plus 1 by x minus 1 is equal to, now numerator, I told you all earlier it is numerator, so a plus 2b plus root a minus 2b plus root a plus 2b minus root a minus 2b. Okay, little adjust, children. Okay, okay. Now here again, here it is numerator minus denominator. Numerator minus denominator means, let me try to go up a little, yeah. Numerator minus denominator means just observe the term above you all, okay, observe the term above you all and change the sign here. So write the first two terms, that is your numerator terms, as they are, okay, as they are, and then change the signs of the denominator. Minus a plus 2b and this becomes plus a minus 2b. Okay, now if you see, we can cancel a minus 2b and we can cancel a plus 2b. So we have x plus 1 by x minus 1 is equal to 2 root a plus 2b by 2 root a minus 2b. 2 and 2 gets cancelled, never ever cancel the root and root, children. Squaring both sides, okay, squaring both sides. I'll go a little up, yeah. See those that I have written there, I have jumped here, okay. Squaring both sides, we have x plus 1 whole square by x minus 1 whole square. So x plus 1 whole square by x minus 1 whole square is equal to a plus 2b by a minus 2b. Again apply componendo and dividendo, okay. When we apply again componendo and dividendo, what happens? Okay, 1 minute. Okay. So when we apply again componendo and dividendo, what happens? There is some technical glitch. So a plus 2b and a minus 2b. This is miserably written. Let us clean it off. Okay. So we have now here a plus 2b by a minus 2b. Again I said by componendo and dividendo. When we apply componendo and dividendo, again here it is numerator plus denominator. So here we have x plus 1 whole square plus x minus 1 whole square by x plus 1 whole square minus x minus 1 whole square is equal to a plus 2b by a minus 2b. You have a plus 2b plus a minus 2b and a plus 2b. After you write the numerator, children, change the sign of the denominator, minus a plus 2b, okay, plus 2b. Now if you see again here we can cancel 2b, here we can cancel a and a. So we are left here, the left RHS I am writing first, 2a by 4b. Now here you have to know little bit of your expansions. A plus b whole square plus a minus b whole square is 2 into a square plus b square. So this becomes 2 into x square plus 1 by a plus b whole square minus a minus b whole square is 4ab. So this becomes 4x. So we can cancel. I'll change the color and show the cancellations. Okay. So we can cancel the 2 and 2 on these two sides and 4 and 4 on these two sides. So what are we left with now? We are left with x square plus 1 by x. Okay. So we are left with x square plus 1 by x is equal to a by b. Okay. Now cross multiply, so we have bx square plus b is equal to ax. Bx square plus b is equal to x. Transpose ax to the other side and there is your answer. Bx square minus ax plus b is equal to 0. So see the answer, bx square minus ax plus b is equal to 0. See the solution. Okay. Okay, by componendo and dividendo you have to do it. Okay. So let's see this question. If a, b, c, d are in continued proportion, prove that 3a minus 7d by 7a plus 3d is equal to 3a cube minus 7b cube by 7a cube plus 3b cube. A, b, c, d are in continued proportion means, children, it is a by b, there is a continuation. So you have b by c, there is a continuation. So you have c by d, which you have to equate it to k. So this is to be done by the k method, where you equate each of the ratios to k. So now a becomes bk, okay, b becomes ck and c becomes dk. Now if you keep substituting backward c as dk in this b, you get b as dk square, and if you substitute in place of b as dk square, a becomes dk cube. So these are the final values of a, b, c that you need to substitute. Okay. So let's see the LHS. What is the LHS? LHS is 3a minus 7d. Okay, I'll not write a. Oh, okay. Okay. So 3a minus 7d. 3a is dk cube minus 7d. d is d only by 7a. Again, a is dk cube plus 3d. Take out d common, 3k cube minus 7 by, take out d common, 7k cube plus 3. d and d gets cancelled. So it is 3k cube minus 7 by 7k cube plus 9. This is the LHS. So this is the LHS. Now we have to find the RHS and also show it is same as the LHS. So what is the RHS given? It is given as 3a cube minus 7b cube, 3a cube minus 7b cube by, so let me write the RHS. So RHS is 3a cube. A is what, children? dk cube. So it becomes d cube k power 9 minus 7 b cube. b cube is d square dk square, so it becomes d cube k power 6 by 7a cube. So it is 7 d cube k power 9 plus 9b square. So it becomes 9 or 3. Oh, this is 3. Yeah. So 3b square. So it is 3 d cube k power 6. Now in the numerator we can take out d cube and also k power 6. So we have 3 k to the power 3 minus 7 by denominator also you can take out d cube k power 6. So we have 7 k power 3 plus 3. So if we cancel the LHS which is here and the RHS, both are the same. Is that clear? So this is called the K method. Just that you have to know that A is equal to dk cube, B is equal to dk square, C is equal to dk, and then you have to go ahead. Okay. So this is the solution. A is equal to dk cube, B is equal to dk square, C is equal to dk. You get the LHS as 3k cube minus 7 by 3k cube minus 7 by 7k cube plus 3, and the RHS also is 3k cube minus 7 by 7k cube plus 3. Okay. So this comes to the end of this lesson, ratio and proportion, children. Hope you have enjoyed this class as much as I have enjoyed teaching it to you all. See you back in the next video. Till then, stay blessed and don't forget to like, subscribe and share to ICSE Math Guru.